Ma, good morning. It will wait for another 2 minutes. Let everyone will join. Yeah, good morning once again, everyone. Back here with a lesson. In the last class, as we have successfully completed a module 3, the module 3 is entirely on the IP protocol, as we have seen their internet working, how it will be done, the basics of an internet working. That means how an IPv protocol will be there, how a header format will be there, and what are the services of an IPv protocol that we had discussed in a part 1, that is assigning addresses yeah, to the logical addresses or IP addresses to the devices in internet. So how a class A, class B, and class D works, and we have discussed the main thing in class A, class B, and class C. And we have discussed about a subnetting also, how a different plans will be taken into consideration, how subnet mask will be useful in that, finding out or calculating a particular IP address using an and operation. That also we have seen. And then we have gone within a second type that's called as a connectionless.
What
Hello?
Hello.
ಏನಪ್ಪಾ ವಾಯ್ಸ್ ಬ್ರೇಕ್ ಆಗ್ತಾ ಇದೆಯಮ್ಮ
Yes, sir.
ವಾಯ್ಸ್ ಬ್ರೇಕ್ ಆಗ್ತಾ ಇದೆಯಾ ಈಗ ಈಗ
No, sir.
ಹಲೋ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ವಾಯ್ಸು ನೋ
No, sir.
ಮಿಟ್ ಮಾಡಿಲ್ವೇ
Hello.
ಈಗ ಹಲೋ
Better, sir.
ಹಲೋ
Better, sir.
ಕೇಳಿಸ್ತಾ ಇದೆಯಮ್ಮ ಬೆಟರಾ ಓಕೆ ಈಗ ನೋಡಿ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ಹಲೋ
Yes, sir.
ಹಲೋ ಹಲೋ ಕೇಳಿಸ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಯು ಕ್ಯಾನ್ ಇಂಟರಪ್ಟ್ ನಾಟ್ ಎ ಥಿಂಗ್ ಇದು ಮಾಡಿ ಅಮ್ಮ ಇವಾಗ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ
Yes, sir. Network
ಹಲೋ
problem, sir. Network problem, sir. Release.
Okay. The next concept which we have discussed ಸ್ವಲ್ಪ ಸೆಟ್ರು ಕನೆಕ್ಟ್ ಮಾಡ್ಬಿಡ್ತೀನಿ, ಇಲ್ಲಾಂದ್ರೆ ವೈಟ್ 1 minute ಹಾಗೆ ಇರಿ. ನಾನು ಇನ್ನೇನೋ ನೆಟ್ಟೇ ಬರ್ತಾ ಇಲ್ಲ. Just 1 minute. ಇವಾಗ ಕೇಳಿಸ್ತಾ ಇದೆಯಮ್ಮ ಕರೆಕ್ಟ್ ಆಗಿ? ಹಲೋ
Yes, sir.
ಹಲೋ.
Yes, sir. Yes, sir.
Yeah. Yeah. Till back with the lesson now. As I am refreshing the module 3 classes, and the module 3 what we have discussed, I am telling that what is the services of an IPv protocol, that is the internet protocol, and the assigning an IP addresses. In that we are discussing a classless interdomain routing, means how a classless addressing can be done. So that we had discussed that how a entire range of IP addresses will be taken, and how it will take a common bits in that particular thing, how many common bits are there, so that will become a prefix of that particular IP address. So that also we had discussed. Coming to the next concept, that is a routing. So how a routing will be done from the source to the destination. Another one important work of the IPv4 protocol. In that we have discussed the major two types. That is, one is a distance vector routing protocol, and another one is a linked state routing protocol. And rather than a combination of that, we have taken in a source routing. That also we had discussed. And coming to the advanced internet working, so further things that we have discussed about a BGP and EGP we have discussed, and then we have discussed about mobile hostings or a mobile routings. So this is the third model which we had discussed as one of the important model. Now coming into the next model, that is a next layer, transport layer. So while discussing about a reference model of an OSI reference model, I have told very clearly that the two important layers will be there. One is a networking, and another one is a transport layer. As in a transport layer, that what is the work, means what is the service of this is, it will take a streams of messages from an application, and it will make a parts of that particular messages, and it will make some packets from a set of a segment of a packets will be there. That is assumed from 1 to 100 packets are there. What's the work of the transport layer, means either all the 100 packets moved correctly from the source to the destination, either the sequence of the particular packets are in the same format. Why? Because even sequence sales is a problem. So the interval of the packets will also be taken into the consideration. Now, how a TCP should do? TCP should know that in which, what is a congestion, where the congestion is happening, where the delay is there. If delay is there, how to improve the performance of this, means how to reduce the delay. So all these services will be given by a transport layer. Coming to the TCP/IP reference model, there as why, because we are now entire textbook is depending on TCP/IP reference model, and today the internet is also. Now coming to the here, the transport layer equivalent is here, two protocols will be there. One is on a TCP and another one is on a UDP. These two protocols will do this particular work services what I told you. Why two protocols? I'll tell you. See, one is an a reliable protocol and another one is an unreliable protocol. The TCP, that is transmission control protocol, is a reliable one. Either the packet reached the destination or not. Based on acknowledgement, it will decide, okay, it's there in a sequence or not. If not, the retransmission of the packet will be done. So all these works will be there in a TCP. But a UDP, user datagram protocol, what is the work of this? Keeping an interval of an packet to packet, it will keep on sending the packets. It never wants that either the packet has reached the destination or not. If packets dropped also, it never cares, and almost all reliable will not be there in this particular concept. Means retransmissions concept will not be there. Now, in this particular model, we will see how this means how the header format of an TCP will be there. Now, how TCP will work with the port number and how UDP will work. And later on that, we will go with the other concepts that how a congestion control can be done in a TCP. All these particular concepts we are going to discuss in this particular model. Now we'll go with this particular model. I'll share the PPT. Share. Now, end-to-end protocols, even end-to-end process, as I told that's a TCP and a unit. Coming to here, how to turn this host-to-host packet delivery service into a process-to-process communication channel. Now, in a previous thing and all, we have studied that how a host-to-host packet delivery is going to be done, how a routing can be done and all. Now here we'll go with a process to process. What is a process? Here some 100 packets are there. Either all the 100 packets are moved correctly or not. That is a process. If all the 100 packets from starting from 1 to the 100 number has moved in correct format and it is there within a destination, then the work will be completed. So that is called as process to process communication channel. Coming to the next, in this particular chapter, the main things we are going to discuss is simple demultiplexer will be there, that is a UDP, and reliable byte stream will be there, that is a TCP. Coming to the chapter goal, understanding the demultiplexing service, that is a UDP, discussing simple byte stream protocols, how a bytes of stream will be keep on going in a TCP. Coming to end-to-end protocols. Common properties that a transport protocol can be expected to provide. As I told you that how a transport layer must be there. Guarantees the message delivery. This is very much important. If one message is having some 100 packets, means either all that mode or not. Next, deliveries the messages in the same order they were sent. As I am telling always, I am pressing on that particular point, whether it's in a sequence or not. Next, deliveries at most one copy of each message. So at least one copy of each message should be there. Supports arbitrarily large messages. Wherever it may be a very large messages, not a problem that it will split that into the packets. Now, supports synchronization between the sender and the receiver. This is very much important. The service, means this transport layer is doing. What is this? Holding up of both the client and server together, a sender and a receiver together until the work completes. What do you mean by this? For example, I will tell you like this. First, the sender will ask the receiver whether you are free. I want to send some data to you. Then receiver will tell, okay, not a problem. I am free now. You can send me. Once the message sending is started, the receiver will not engage with other, and here the sender will not engage with other. They will be tied together. That is called as a synchronization. Until all data has been sent, means all message has been sent from source data. Once it has been sent, then the sender will tell, thank you very much, I have completed my work. Thank you very much for supporting me. The receiver will tell, okay, I have received all the data correctly, not a problem. Now, okay, we'll leave. Handshake together, bye. So then they will go off. In this way, the connection release will be there. Now coming to the next concept, allows the receiver to apply flow control to the sender. This is another one important concept. I used to tell you that how a flow control should be there. For example, assume that the receiver is less efficient than a sender. Means sender can send more packets at a time, but receiver cannot receive that. As I given a ball example, that if you throw a 3 balls at a time to your friend, how he can catch is having only 2 hands. So third ball definitely will drop. So what you have to do? You have to throw one ball and or you have to throw 2 balls and you have to give some time. Then afterwards, after catching that ball, again these 2 balls, another 2 balls should go and reach him. Meanwhile, what is the flow control? Actually, I'll throw 2 balls. Still, the balls are on the way. I'll throw another 2 balls. So you can catch 2 balls within a hands. Another 2 balls will come. Means no. Then definitely there will be a drop. So in this thing, how a flow control should be there, how a time should be controlled between the sending of a packets where receiver can receive it correctly. So these are the very important parts. See, telling it's very easy. Means as a human beings we can understand and we can tell slowly, man, I can't understand. Okay, slowly they will tell understood or not. Like that it will be there. But what about the systems? So how a flow control will be done automatically? Why? Because it's a heterogeneous networks. So this is a challenge here or a constraint. So coming to the next, supports a multiple application processes on each host. This is another one very much important thing. Either the person is using a chat box, either a person is using an email, either a person is using an FTP means sending an files, either a person using an browsing, whatever application you are doing, all the application protocols should come with this particular transport layer only. That means your transport layer must know that after means once the packets everything is reached correctly, to which application it should send. That means identifying the multiple application is again another one important service of this particular transport layer. Coming to the next thing, that is typical limitations of a network on which transport protocol will operate. So what is the limitations? It will say means how a constraints will be there here. Drop messages. So this is a one major challenge in a transport layer. Once the packet has been dropped, how to retransmit that, then reorder messages, how reordering of the messages should be done. Deliver duplicate copies of a given message means duplicate packets will go to the receiver. Limit messages to some finite size. So how to make a maximum MTU means maximum transmission unit. Deliver messages after an arbitrarily long delay. If long delay is there, so then again the performance will goes down. How to minimize the delay? So these are the challenges. Coming to next challenge for a transport protocol. So you can see now develop algorithms that turn the less than desirable properties of the underlying network into the high level of service required by application programs. What do you mean by this? Is a very much important point. That is that whatever your different application protocols is expecting that all the message should be gone correctly to the receiver. Correctly, the word correctly is important. Correctly to the receiver without errors, in a order, without a delay. So this is a challenge for a transport layer. Coming to the next thing, that is UDP. So simple demultiplexer. In other words, user datagram protocol. Now, how this particular things will work here? Extends host-to-host delivery service of the underlying network into a process-to-process communication service. So whatever underlying thing, see, I will tell very clearly what is the difference between a network layer and a transport layer. What is the difference between means how a network layer will work? It will take some one particular packet. Either that packet has reached from source to destination. It will concentrate on that. But what is a process to process communication? 100 packets are there in a transport layer, either that all 100 packets has reached to the destination or not. Here the difference. So that is the thing. Adds a level of demultiplexing which allows multiple application processes on each host to share the network. That means how a different, for example, assume one video and audio, whatever now is there, we want to send that to the other person. Best example, you can take a YouTube video downloading. For this, UDP will be a good example. How anything here? There, both the application, that is audio streaming and video streaming, equally should be done. This is very much important. What do you mean by that? The movie, whatever is coming, the picture, whatever is video is, whatever is running, the audio should be associated with that. Means we should be related with that. Otherwise, there will be a mismatch in a video play and as well as an audio play. Many examples you can see that video will go in front and audio will come later, where a mismatch will be there. You will feel means the user will feel that it's not a good. Means you can't follow up. You can't watch that particular movie. Then how these things should be done? So these two things combinedly will come to you, means at a receiver. To you means receiver. So when combinedly it will comes to receiver, the audio and the video should be bifurcated there, and it will be processed at a receiver separately. So this is an examples for hard cell level of demultiplexing, which allows a multiple applications, right? Now coming to the UDP header format. Now you can see here, as in a network layer, we have seen that how important the IP addresses is, IP address is. But here in this header format, we never care for an IP address. Now with a header format of an IP protocol with the payload is molded or encapsulated. On that, this will be there. What is this? Now you can see source port number, destination port number. This is very much important. What do you mean by this? A source port number, IP, until your system it will come to a network, not an issue. So until your system, the packet will come, and then which port it has to go. Either this is a web based, either it is an email based, either it is a chat application, either it's a video application, either it's an audio application. So based on your port number, system's port number, this will be decided. So your system will be identified with a port number also, which is a gate to the different applications. That's why here the port number plays a very much important role. So your source, each means system will have its own port number as a gate to the applications, that is a unique in a nature. So your source port number and destination port number of 16 bits, 16 bits will be taken into the considerations, and length of the entire payload checksum will be there. That's it. And remaining thing will be a data. So this is UDP here. Now coming to the next. Now you will see how the application process will be done with an UDP. Now observe here, this is a ports which you are going to take into the consideration. Application process based on applications, different ports it is going to take. Best example I'll tell you, always for an Apache server, the port number will be 8080. And for a web thing is 80 is a port number. Like that, telnet, maybe around I think 72 is a port number. Like this, there is a specific port numbers will be there. Now coming to here, you observe carefully packets demultiplexes, how it will done. Packets will arrive on a UDP here. What your UDP will do, it will check based on a port numbers, and demultiplex will be done based on a port numbers. For example, assume this is an audio, this is an a video, and it is in a chat box. Just for an example, I'm telling you. Now it will check a packet, either a packet is an audio packet, it will throw into the audio queue. And either it's in a packet is in a video, then it will throw that into the video queue. And it's a chat, and then it will throw into the chat application queue. So then it will go one by one to the application. So in this way, the UDP demultiplexer will work based on a port numbers to identify a different application processes. Any doubt here, you can ask me. So this is all about on a UDP. Now coming to the TCP. The TCP, that is a reliable byte stream, and it will work. Means it's a reliable one. Transmission control protocol. So how at this transmission control protocol, what are the services? You observe here clearly, reliable, connection oriented, byte stream service. So here these terms will place in a very much important role. Now you can see here, there's a connection oriented. That means this particular TCP must know that from which node to the which particular node in between the packet is moving. That entire path, it's already know about that. And a byte stream. Now how services? You know the byte stream services, what I have told that bytes of data will be keep on moving, identified through the bytes. So reliable means whether the packet has reached correctly or not, based on acknowledgements it will work. Now flow control versus congestion control. This is one of the very important thing. I'll tell you like this. Flow control is the one that is a lamps in a road. So congestion control is like that, a bottleneck point. So this is important. That is, flow control involves the preventing senders from overrunning the capacity of the receivers. That is the flow control, throwing a balls. That the best example which you can take into the consideration. So based on a receiver's capacity, the data should be sent from a sender. What is a congestion control? Now you observe it. Congestion control is a traffic jam. Congestion control involves preventing too much data from being injected into the network, thereby causing switches or links to become overloaded. So what do you mean by this? In between the routers will become overloaded. So to minimize the sending of packets, best example I will tell you. For example, a congestion. You consider one router is there. Assume router is there. Through that router only you have to go to your destination. That is, assume that your router is having some capacity and a queue capacity is there. Assume from different three ports the other data is also coming. Just for a sake I am telling you, once the packets are coming here in a full fledged, what happens, this router, it has to check each and every project means packet, and it has to send to which port it should be sent, you know that. So for that it needs some time. Then meanwhile any packets will come, it will put that in a queue. So it will keep in a queue. What, based on a capacity of queue, it will keep on putting. Once the capacity of a queue is over, then what, there is no other way that it can't keep that packet. Definitely the packet will drop. So once the packet will drop, there is a huge headache that the retransmission of that packet should be done. So this point where the packet will drop is called as a congestion. So to minimize this congestion, if the flow is coming less, so injected means the traffic is less there will be a no chance of that the traffic jam, that is overloading of that particular router. So that is important here. That is the difference between flow control and a congestion control. Coming to the next, end-to-end issues in a TCP. Now, at the heart of TCP is a sliding window algorithm. This is one of the important, in chapter 2, we have discussed the sliding window algorithm, that how a sender window will be there, how a receiver window will be there, based on the sender window, or the receiver window will be there here, based on a sender window will be there. So it will keep on sending packets. Receiver will receive based on that, and what is the expected here, and LAR and all I have told you very clearly about that, which is the last acknowledgement received, and which is the last frame sent in a sender side here, which is the last frame received, and which is a last acknowledgement sent. So that in a receiver side. So based on that, it will work. Same concept will be there in a TCP. Now, how the TCP will be there? TCP will check here whether all that 100 packets concept. So that packets has moved or not, either what should be sent back. As TCP runs over the internet rather than a point-to-point link. This is important. The following issues need to be addressed by the sliding window algorithm. What is that? TCP supports logical connections between processes that are running on two different computers in the internet. Processes, underline the word here, the processes, until all the 100 packets has moved. So this both, there should, means the sender TCP and a receiver TCP should be synchronized. So it should be there. TCP connections are likely to have a widely different RTT times. So that is round trip time will be a different one here. Why it's a different one? It's a far distance. That is in between how many hops are there. So how many nodes it should cross and it should go and reach there. How a retransmission, everything will be counted here. Here concept is not single packet. Here concept is all 100 packets. In that 100 packets, how many are retransmitted, how many fall, how many are in a loop. So that and all should be taken. For sending all 100 packets correctly to the sender, to the receiver, what is the time required? So here RTT will be somewhat different way which we are going to calculate. Packets may be get reordered in the internet many times. Coming to the next thing, that is TCP needs a mechanism uses, just a minute. Yeah. TCP needs a mechanism using which each side of a connection will run what resources the other side is able to apply to the connection. So this is very important. What resources both are synchronized and both are using, either a buffers, whatever is there, and other resources of a memory and all you can take. Now TCP needs a mechanism using which the sending side will learn the capacity of the network. This is another one important. The sender should learn the capacity of entire network. Somewhere the congestion will occur, automatically the window size of the sender should be reduced. Why? Because there is some traffic jam is there. No, I will control, I don't send this packets there. If control has been done by all the senders, then automatically the traffic will come down, the package flow will come down, there the congestion will be released at that particular router. So this mechanism is one of the very important service or an algorithm which is given by an TCP. Very again, I will tell you, assume that some 4 or 5 senders are there and one router is there. Just as I say, at a router congestion is occurred means automatically the sliding window means packet sending window size will be reduced by these senders. Why these senders it will reduce? That is to minimize the flow. Once the flow has been minimized, then automatically the congestion will be released at the router where packets will flow easily. So this is the another one important concept. Coming to next, TCP segment. Now TCP is a byte oriented protocol, means bytes in a byte counts we are going to send a data, which means that the sender writes bytes into a TCP connection and the receiver reads bytes out of the TCP connection. No bits concept, bytes. 8 bits will be taken, 1 byte, like that, 1 byte. Although bytestream describes the service TCP offers to application processes, TCP does not itself transmit individual bytes over the internet. So individual bytes it never transmits. A sequence of segments of bytes will be taken into the consideration. Now TCP on the source host buffers enough bytes from the sending processes to fill a reasonably sized packet and then sends this packet to its peer on the destination host. Very important. What is this? Assume one MTU is the maximum transmission unit. That's a packet size. What it will do, whatever a bytes it's coming, it will fill that first. Assume that, for example, Ethernet packet size is 1500 bytes. So 1500 bytes payload. So 1500 bytes should come from an application. After taking 1500 bytes, it will pack up. Yes, one bucket has filled or one packet has filled. Now it will give a number, everything to that. For entire, assume that I will tell you like this. For there is some 2 lakh bytes are there. Just for a sec, I'm telling. Or you take some 50,000 bytes out there sample. So 50,000 bytes means how many 1500 packets it should make in one particular message. Like that, it will make that. So that entire packets will be in one process. So TCP on the destination host then empties the contents of the packet into a receiver buffer and the receiving process reads from this buffer and its leisure. Once it goes to the receiver side, the receiver what it will do, it will picks up the contents of that, it will make empty of that packet and that contents will be stored in a buffer. It never gives to the application. Keep in mind. Why? Because that entire 50,000 of bytes should come. Here one packet is only 1500 bytes. Assume that one packet gone correctly. Next packet gone correctly. So still now all for 50,000 of the capacity bytes means that many packets just came and 50,000 bytes is there now. Then it will be sent to the application. Still then it will be there in a buffer of a receiver. The packets exchanged between TCP peers are called segments. Now you can see here how the send buffer and receive buffers will work. Segments means here you assume it's a packets. Now application processes whatever is here write a bytes. So this it will take in a form of a bytes. Maybe lap together bytes will be there. Don't worry about that. So it will take a bytes. It will fill up here means in packets and it will send that segments here that packets and I transmit segments. Once it comes here, receiver will have a buffer, it will take and it will store in a buffer. Once the bytes, everything has been stored here, reading of a bytes will start by the application. Like this, the segment will be worked. Coming to the TCP header, now we gone there with a UDP header. UDP header is less compared to the TCP. Now you can observe here. Here sequence number acknowledgement plays a very much important role. Why? Because it's a reliable. There it's not a reliable. That's why these two things are not there. Now source port number, I told you that. What for this? Destination port. Now coming to the sequence number, each and every packet will have its own sequence number. So that will be there here. Coming to the acknowledgement. So either this particular header is an acknowledgement or not. So that will be taken into the consideration. Like remaining fields will be used for other use. So in this way, the TCP header will be there. Header length, flags indicates that either it is an acknowledgement packet or sender packet. Advertised a window for a broadcasting purpose. Checksum to find errors. So urgent pointers means either there's an emergency, priority should be given to that particular. So the remaining are optionals here. Coming to the TCP header in detail. That is the source port and the destination port fields identify the source and destination ports respectively. Coming to the next, the acknowledgement sequence number and advertised window fields are all involved in a TCP sliding window algorithm. This is very much important, where a sequence number will also place where either that packet dropped or not in a repetitive or in NPK method. Everything I have told you very clearly that a particular packet has been dropped selectively, that should be resent, retransmitted. For that and all, sequence number plays a very much important. Because TCP is a byte oriented protocol, each byte of a data has a sequence number. The sequence number field contains the sequence number for the first byte of a data carried in that segment. Means each packet will be identified. The acknowledgement and advertised window fields carry information about the flow of a data going in the other direction. That is, means from back receiver to the sender. So how this acknowledgement will come back? So it will means entire payload will be taken by the receiver, only header will be cut and it will be sent back, making a acknowledgement flag as 1 and acknowledgement number will be filled into the acknowledgement field and it will be sent. Same thing with an advertised window also, means how much capacity I am having still to receive the packets. Next, the 6-bit flag field is used to relay control information between TCP fields. That is how a control will be there. The possible flags are sync, fin, means reset, push, urge, and acknowledgement. So acknowledgement bit will tell whether the header is acknowledgement or not. Urge, whether it's urgent priority should be given to that. Sync is whether it's a synchronized or not, means the flow. Then for a flow control, fin. If flow control is missed, fin will be taken. Reset means again for a retransmitting of that packet. So the SYN and FIN flags are used when establishing and terminating a TCP connection. So when this will be used, first for handshaking purpose, SYN and FIN will be used. I will tell you that how a handshake will be done. The acknowledge flag is set at any time the acknowledgement field is valid, implying that the receiver should pay attention to it. So identify which header it is, either it is a packet header, either it is acknowledgement header. To identify that, this acknowledge flag will be used. Coming to the next, the URG flag signifies that this significant contains urgent data When this flag is set, the urge pointer fields indicates where the non-urgent data contained in this particular segment begins. So, which is the urgent data? Either this packet should move urgent or not. Priority should be given that. The urgent data is contained at the front of the segment body up to and including a value of the urge pointer bytes into the segment. Next, the push flag signifies that the sender invoked the push operation, which indicates to the receiving side of TCP that it should notify the receiving process of this fact. What do you mean by this? The receiving, while taking a this particular packet at a receiver side, this should be taken without checking. Means it will be taken inside. Why? Because there's a very priority should be given data. It should be pushed inside. Finally, the reset flag signifies that the receiver has become confused. So once the receiver will not understand anything, the mismatch is there between sequence numbers and all. The receiver will send a reset means flag will be set by a receiver in acknowledgement, and automatically the TCP will reset its entire sending process. So finally, the reset flag signifies that the receiver has become confused. It received a segment it did not expect to receive and so wants to abort the connection. Means start from beginning. Finally, the checksum field is there to check as in a UDP only to check whether the error detection is there or not. So this will be there in a header. So there will be a direct question for you, that is explain the TCP header format with a neat diagram. So that's a question, you should explain all the fields. Coming to the next, connection establishment and termination in TCP, we'll do in a next class. So any doubts is there? Now you can ask me. Any doubts is there? Any doubts is there? Hello? Any doubts is there? Listening? Okay, ma. Okay, thank you very much. Tomorrow class will be at 8:30. Okay? Hello? Okay.
Okay, thank you.
Okay, thank you.